everyone, I'm Bajić. Today I'm here to tell you an intriguing story about combining two very different frameworks together. I'll share my personal insights on how to navigate through it, highlighting the advantages, struggles, and lessons learned along the way. Now let me share with you my experience with Python frameworks. The first framework I had an experience working with was Flask. I use it for my hobby projects and for my diploma thesis. What I like about Flask is that it's a very lightweight and very simple framework, and it's also very easy to use. Then I began working in a company that used Django. We were creating typical CRUD apps, and Django was great for the apps we were creating. Everything worked out of the box. Django ecosystem was great with lots of libraries, and in general, we didn't have to tweak things a lot. Everything just worked. And finally, I joined my current company, Atacama, where we use FastAPI, but with one exception I will talk a bit about later. These three frameworks are currently the most used one in Python ecosystem. According to a JetBrains survey from 2023, Django leads the pack used by 40% of responders, followedly close by Flask with 38%, and FastAPI with 25%. However, the most interesting fact about FastAPI is its rapid growth and its huge adoption, rising from 14% in 2021 to 25% in 2023. And now, I'm curious about your experiences with frameworks. How many of you have experience with Django? Raise hand. Okay, so around 90% of people, so almost everyone. And how many of you have experience with FastAPI? Okay, around 50%. And now comes the fun part. How many of you have experience using both Django and FastAPI in a single app? Oh, yes? No? No. Okay. So no one. And indeed, if you have a look at the most popular FastAPI open source projects on GitHub, you will notice that none of them use Django ORM. Most of these, in fact, use SQL Alchemy. And now, you might be wondering why. Why is Django and its ORM so popular, yet it's never used with FastAPI? To find out, let's dig deeper into each of these frameworks. FastAPI is a newer framework released in December 2018. It's very modern and very flexible. It's built on the shoulders of two giants, Pydantic and Starlet. Pydantic is a Python package used for data validation, serialization, and documentation. Starlet is a lightweight asynchronous framework or toolkit used for building web services. That means basically that any of its components can be used independently. Its main features include things like WebSocket support, session and cookie management, test client, core, JZip compression, static files, streaming responses, background tasks, and many, many more. As you can notice on the diagram, Starlet uses UVcorn and implements SGSpec. The most notable feature, or the feature for which FastAPI is best known or the most used, is its performance. FastAPI is one of the fastest Python frameworks, and its exceptional performance is largely due to its asynchronous capabilities. Django, on the other hand, is a framework with its first release in 2025 and has been the most popular Python framework for years. It is a batteries-included framework, meaning it comes with a comprehensive set of features right out of the box. Additionally, Django is quite opinionated. It was designed to promote specific patterns and specific approaches to web development. When it comes to its ORM, it's primarily synchronous. Asynchronous features have started to be added from version 4.2, which was released in April 2023. However, full implementation of asynchronous features is still ongoing. Now, the question is, what are the benefits of using Django ORM with FastAPI? So the situation where basically you have FastAPI, so why would you use Django ORM with it? From my personal experience, Django ORM is very easy to learn. I switched to Django ORM after using SQL Alchemy, and I find it easier to learn. And also, it's mostly because there are fewer things one needs to take care of. For example, session management. You need to take care of it by yourself in SQL Alchemy. I also have experience with Alembic and Django migrations, and I find Django migrations easier to learn and easier to manage. Also, Django has a very rich ecosystem with lots of tools you can use. If you type Django on PyPy, you're able to find over 10,000 packages containing the word Django in them. If you head over to djangopackages.org, you can find lots of different projects to explore. FastAPI is a relatively new framework, therefore its ecosystem is smaller. One of the killer features of Django is its admin panel. It is a panel where you can add, delete, or update data belonging to any module. It's a friendly user graphical interface, which is great because it can be used also by users who are not programmers. FastAPI doesn't have any built-in panel, so if you want to have one, you have to use third-party packages. Django is also well-maintained and supported by a large community. This community not only contributes to the framework's development, but also organizes events like DjangoCon, where developers can gather together. DjangoCon also includes sprints, where everyone has an opportunity to contribute to Django or one of its libraries. I personally have been to the sprints, and for me, it was a great opportunity to poke around the code base and to learn more about how Django works under the hood. Django also has great documentation. You can find lots of resources and support online. There are forums, tutorials, Discord groups, and even podcasts all about Django. If you want to check it out on your own or connect with the community, head over to djangoproject.com/community. This is where this screenshot is from. And this is one of the things I personally am missing a lot with FastAPI. It's a new framework, so its community is very small. Now, if we take it from the other side and ask ourselves, what does FastAPI bring to the table, and why should we use FastAPI instead of Django? The biggest reason you would probably want to use it is its improved performance thanks to its asynchronous capabilities. FastAPI also includes a powerful feature that automatically generates documentation for your API endpoints. This interactive documentation is provided in the OpenAPI format, and it simplifies your initial setup. So if you open your app and navigate to /docs, you can explore and interact with your API. Alternatively, if you prefer a different style, you can use /redoc to view the documentation in redoc format. And it also utilizes the OpenAPI specification. And this feature is not built in Django. FastAPI utilizes a nice feature called dependency injection, which really helps to keep your code clean and testable. In order to see how it works, let's see an example. Let's say we have a service that fetches data from an external production API. We have a route that utilizes this service. Each time the endpoint fetch data is called, and an external call is made. Now, how can we test this in an easy way without actually calling the external API? Here is an example of what our test might look like. First, we create an async mock object that has some return value. And if we want to swap our dependency and use the async mock object instead of our production service, we can call dependency overrides. Then we proceed to ask our endpoint as usual. So in just one line, we managed to swap our service with another. I think this is a very nice pattern which improves testability and helps you a lot to keep your tests clean. I've not seen this pattern being commonly used with Django. The last feature I want to highlight is FastAPI simplicity. Sometimes working with Django feels like there's a lot of magic happening behind the scenes. This might be helpful when you're trying to set up something. However, it can also mean that everything is fine and everything works until it suddenly doesn't. And then what? Then you start debugging. However, with Django, to me personally, sometimes it's very hard to figure out what's happening under the hood. With FastAPI, it has a very straightforward approach, and it makes it easier for you to understand how is your application put together and how it works. And I think this can be a great advantage when troubleshooting. Now, I told you lots of benefits from using these two frameworks together. But there is a reason why this combination is not commonly used. Let's explore some of the unique challenges it presents. The first thing you notice once you're starting working with a code base that mixes asynchronous and synchronous code is how often this exception occurs. And it occurs in places you didn't even know existed in your code base. How many of you working with Django have ever encountered this exception? One person, 2, 3, 4, 5 people, so not so many. If you decide to use both, then you're almost guaranteed to run into it sooner or later. One of the big reasons why I believe this setup is not commonly used is because managing synchronous and asynchronous code adds another layer of complexity you have to take care of. Let me share a quick story called There and Back Again. When I joined our team a year and a half ago, our code base was sync first. That meant all of our methods were synchronous, and when we needed something asynchronous, like for example API routes in FastAPI, we use our asynchronous, we just use sync to async decorators. I witnessed a situation where my colleague was working on rewriting the entire code base to an async first approach. Back then, Django had released support for async ORM, and the idea was that now, when we can have everything async, why not try it out and have the whole code base async instead of having it sync, and half async. The change initially seemed successful. Everything worked. However, the devil is in the details. While Django has added lots of async features, there were many features it still didn't support, like async transaction, for example. So everything had to be reverted back to sync first. One of the great features of Django that I already mentioned is its very rich ecosystem. However, these tools don't work with FastAPI. There are cases where these tools don't work at all. So for example, I tried to use PyTest Django XDist, and it did not work because FastAPI uses Starlet's test client. And there are cases where these tools work, but they have to be tweaked a lot. So they don't work out of the box as they work with Django. When you encounter a problem, what's the first thing you typically do? You Google it. However, with this setup, you will find that there are not many examples on the internet. So you're left on your own, and basically, you just have to experiment. And the last point I would like to touch on is the initial setup. With Django, you can simply use commands like start project, and you're ready to begin. Similarly, with FastAPI, a few lines of code are enough to get things moving. However, with any custom setup, such as this one, where you're combining unusual elements, it will inevitably take more time to get everything up and running. Now, let's explore how this setup might be implemented. First, let's have a look at the diagram. We have a FastAPI application that uses Django ORM for database communication. Where do we start? We are integrated into different frameworks, so we must configure them separately. We begin with Django and its database layer. First, we modify the settings.py file used by Django. I've only changed the database name. Everything else remains unchanged. Next, we need the wizgy.py file to import the Django settings module and launch the application. Now, let's turn to our main.py file where we consolidate everything. Here, we set up the Django settings module, call Django setup, and populate the apps with our installed apps. Now, Django is ready. The second part involves setting up FastAPI. We start with creating a FastAPI instance, then we define our routes and connect them. For deployment, I prefer using Docker. The Docker file specifies our base image and working directory. We copy our requirements, install them, then copy all necessary files, and export port 8000. Finally, we launch the app using UVcorn, specifying our main file, host, and port, and our app is ready. So if we open now localhost and type in /docs, we can see it works. Moving on. How do we create an endpoint that lists some data stored in a database? Let's see an example. First, we define our endpoint path, add some description, and a response model using Pydantic. Then, we make a database call, which is wrapped in the sync to async decorator. It's a coroutine, so we must await it. And the fetch data is then serialized as a Pydantic module. For Django versions above 4.2, you can use aget directly without the decorator. The implementation manages synchronous and asynchronous code under the hood, so you don't have to take care of it. However, keep in mind that while Django has added lots of async features, it's an ongoing process and not everything has been implemented yet. When you call the endpoint, you can see there's some data return. Now, let's move on to tests. The principle here is the same as for setting up our main app. First, we need to set up Django. We do this by defining where our Django settings module is, populating apps, and finally running migrations before each session. Because we want the database to be clean for each test run, we need to create a fixture which truncates all tables after each run. Then we move on the second part of our setup, which is the FastAPI side. We create a fixture where we basically import the app as is. And the last part involves setting up a client to which we pass our imported app and configure its base URL. Now, when the setup is ready, let's look how we can create a test that evaluates the creation of a module. First, let's look at a unit test. We will write a test which will assess a service method that adds a new book, and it does it without a database. For that, we will use a fake repository which might look something like this. So basically, instead of persisting data into a database, we store it in an array which we can access later. We start with creating a request with some data. Then we call our book service, but instead of using its normal repository, we use a fake one. Then we call the method and pass the request data, and after that, we can access the array where the data is stored. Finally, we can assert whether the stored data equals the data from the request. If you would like to write an integration test to test your entire endpoint and to use a database, you could write it like this. First, we create our test that uses a database fixture that takes care of truncating tables, sets up the book app, and includes a client fixture. It also uses the fixture books, which creates some books just to have some data to test on. We call the endpoint /books and assert that the response code is 200. We can also define the expected data and then compare the expected data with the received data. And that's how you could set up a test. So we've seen how it might be implemented, but you're probably wondering about the right structure. If you start up with Django, you'll find that the structure is already set up for you. That's because Django likes to guide developers with certain best practices, including a predefined structure. FastAPI, on the other hand, is super flexible and doesn't really point you in any specific direction regarding how to structure your project. When it comes to bigger projects, I personally lean towards a module-based approach. It's predictable and extensible. It's used in, for example, Netflix project Dispatch, which is one of the biggest open-source FastAPI projects I've stumbled upon on GitHub. And this kind of structure is also mentioned in the FastAPI best practices repo, which I'll link to a bit later. And this structure works pretty well even if you use Django ORM. All right, so we have discussed the benefits of its setup and the challenges. I can show you how it could be done, but the question remains, should it be done? I personally love working with both frameworks. However, if I were to start a new project from scratch, I would probably check out Django Ninja as it gives you the best of both worlds. Alternatively, I would either go full Django or FastAPI with SQL Alchemy, depending on your project requirements. It might happen, though, that you find yourself working on a project that has already integrated two different frameworks together, like me. Or you're maybe migrating from Django to FastAPI, beginning with the API layer. In these situations, I encourage you to experiment with mixing technologies. It's great fun because you have to tweak things a lot and you learn a lot about it during the process. And I'm very interested about your experiences. Have you tried combining different frameworks? How was it for you? Did it work? I'll be here around till the end of the conference, so please come and talk to me. And at the end, to quote my esteemed colleague who joined our team and expressed this during our first retrospective meeting. It's crazy, but it works. I'm Mia Bajić. Thank you for your attention.
Thank you. There are no slides, but there are in the live. Any questions? Or it's okay?
Hey, nice talk. Well done. One question about the history of the project. Do you know why the decision was made to use FastAPI? Because something like Django REST framework is pretty helpful as well and has automated documentation and things like that. And it looks like a lot of the benefits of FastAPI you had to almost turn off. Yeah, that's basically my question.
Yes. So the app that we are developing basically is a data visualization app which works with real-time data. And the biggest requirement is performance. It really needs to be fast because it works with real-time data. And the reason why to use FastAPI is because it's one of the fastest Python frameworks, therefore it makes sense. Now, the question maybe is more like the opposite. If you already use FastAPI, why do you use Django ORM and not, for example, SQL Alchemy, which is commonly used? The reason why to use Django ORM, as far as I know, in our project was because there was a requirement to have admin panel, because lots of our users are not programmers, but they often have to debug something, for example, consultants. And for them, Django admin is a great tool because you can just go there and to check out what is in the database. You can interact with your models without having to connect to the database and to manage the infrastructure stuff. So the reason why to do it was because of the panel, admin panel, basically. Thank you for your question. It's a great question.
Okay. So in the last... Yeah. Sorry?
Hi, I have a question. Is the example of that setup available anywhere on GitHub?
Yes. So here, the first QR code is go to my slides. And if you open that QR code, basically it will lead you to my GitHub page, and there you have slides, and next to it there is a setup which you can check out.
Thank you. Thank you, Mia.
Thank you.